All right, this is the last section of chapter 7. This video is going to be a little bit longer, so I'm going to try to get through these problems as quickly as possible, but there is a lot of material and a lot of new theorems that we need to discuss. So let's talk about the first one. The first one is going to just talk in general about triangles being split up proportionally. So if a line is parallel to one side of a triangle, so if TU is parallel to another side of the triangle, in this case QS, then it divides the two sides of the triangle, in this case QR and SR, it divides them proportionally. Now, since it divides them proportionally, we can set up ratios. So there's a few different ways you could set up these ratios. That's actually one of the good things about this section of the chapter, is that there are so many different ways to do it that it's almost impossible to get some of these questions incorrect. So, for example, you could say you have QT. You could match up QT with the corresponding side across from it, which would be SU. And if you match up QT with SU, you then have to match up TR with UR. Now, the good thing about this is that if you flip these and made these the reciprocals, that proportion would also work. That's just saying SU over QT is UT or UR over RT. The other thing you could do is, instead of going across the triangle, you also have the option to go on the same side of the triangle. So you could set up QT with TR, and you could also say that is equal to SU over UR. And this makes sense because if you look at the cross products, SU times TR is the same as SU times TR, and QT times UR is the same thing as QT UR. Conversely, if you do have this proportion and it says that the sides are in proportion to each other, then you can conclude that the third side is parallel to the side that is going to cut it proportionally. So if a line divides two sides of a triangle proportionally, then it is parallel to the third side. So all that's saying in this picture is that if RT is proportional, or is in a ratio with TQ, and if that's equal to RU over US, then very simply QS, this one, is running parallel to TU, which is that one. So let's go ahead and try some of these. Again, there's a few different ways you could set it up, so I'm not doing it the only way that's possible, but I will show you a few different ways to do them. So find the length of QU. So I'm just going to put an X here for QU. And I'm going to go across the triangle. So 10 to 12 is the same as what to 6? Well, 10 times 6 is 60, and so 12x's equals 60, and so x equals 5. Without even setting up a proportion, we could also look at it this way. We could say, well, how do you get from 12 to 6? You divide by 2. So 10 divided by 2 will give you 5. Go ahead and just try this one real quick. This one, not so easy to see the relationship, so you need to set up the proportion. And I always like to put these little arrows that tell me what direction I'm going in, so that way I keep the proportion set up correctly. This is asking us whether the sides are parallel to each other. So if they were parallel in this case, you would have to make sure that the ratios matched up. There's a few ways you could do this. Again, just testing whether to see if the cross products are equal. You could divide them out and get decimals. This one's a little bit easier because I can see that 18 matches up with 36. And so 38 has to match up with 40. I recognize that 18 is half of 36. And I also recognize that 38 is not half of 40. So these are not proportional. If you didn't recognize that, just go in here and cross multiply. You'll see that the cross products are different. This one we need to label the diagram. I'm just going to take this triangle and make it a little bit larger. So it's sort of going like this. And then I'm going to label this. This is 31, 19, 27, 23. Again, no matter how you set up this proportion, you're going to get the correct answer. As long as you don't go diagonally in the triangle, you should be fine. This one's very, very similar, except there's not actually triangles. It's just three sets of parallel lines, with two transversals. So if these three parallel lines are intersected by two transversals, then they divide the transversals proportionally. What that means is that UW is in a proportion with, or in a ratio with WY. And so if we're comparing those two sides, we could set that up and say that VX is proportional to XZ. This next one is talking about an angle bisector. So if a ray is bisecting an angle of a triangle, so if these two angles are congruent to each other, then these sides become proportional. AD over BD becomes proportional to AC over BC. All right, let's go in here and let's do this ladder problem. It says a farmer's land is divided by a newly constructed interstate. The distances are shown in meters. It wants to figure out what is the distance of CA. So CA is going to be all of this. And we can only find CA if we can find this segment right here. So let's go ahead and set up this proportion. Again, there's a few different ways you could do it. I'm just going to go X with 3,000. And then 2,000 with 2,500. If I cross multiply 2,000 times 3,000, I get 6 million. And so that equals 2,500x. And if I divide 6 million by 2,500, I get 2,400. So that means the distance from B to C is 2,400. But remember, the question wanted the distance from A to C, so you're going to have to add this 2,000 plus this 2,400 to see that there are 4,400 meters between the two interstates. This is probably the hardest one so far that we're going to do, just in terms that you need to think a little bit outside of the box. So it tells you that this entire thing is 14 down here at DF. So let me ask you this question. If this was 6, what would GF be? GF would be 8. And if I said X is 10, you would then tell me that GF is 4. And if I said that this is, let's say 7, you would say that this is 7 because it's what's remaining from 14. So if that side is X, the other side, GF, can just be replaced with what's left over from 14. And so now we have enough to set up the proportion. We're going to say 8 over X equals 12 over 14 minus X. Go ahead and cross multiply. 12 times X is easy because it's just 12X. Make sure when you multiply 8 times the entire denominator on the right-hand side that you properly distribute 8 to 14. and get 112. And also 8 needs to be distributed to negative x, so it becomes negative 8x. And so in this case, you just add 8 to both sides to get 20x. That equals 112. And if you divide 112 by 20, you'll see that x equals 5.6. Just make sure you read what the question is asking. If x equals 5.6, it might say, hey, what is GF? And in that case, GF would just be 14 minus 5.6, so this would be 8.4. Go ahead and try this one. You're looking for AB. Where was that other problem? I think I lost it. Here it is. Okay, moving right along, we have the side splitter theorem. The side splitter theorem is just what it sounds like. You split two sides equally in half. So let's take a look at this example right here. This is the diagram. So let's say I told you that AC equals 10 and CE equals 14 and BD equals 8. Well, the side splitter theorem says that you need to have a line that runs parallel to the side of the triangle that splits the sides in half. Now, do not get confused because it does not mean that this has to be congruent to this. What is that? Like, looks like a frog or something. That's a fly. I'm obviously very bored. So let's get back to the notes here. These sides don't have to be the same, AC and CE, but they do need to be split in half. So if AC is 10, you would split 10 in half and get 5 here and 5 here. And if CE was 14, this would be 7 and this would be 7. So it's important to remember that these two numbers do not need to be the same. It's actually the sides that are going up and down, not the sides going across from each other. If this is true, then whatever is the segment length in the middle, so I told you in this case BD equals 8, this just equals half of the segment down at the bottom. So this means that this would equal 16. So again, in order for this to work, these sides need to be split evenly. And if this was 10, this would just be 20. Now, when you're solving these problems, it's important that you just think in your head about what this is actually saying. So this theorem says that this x minus 2 is half of this side right here, which is 5x minus 13. Now, you could distribute the half to everything, but I just think that that's making more work than you have to. So I would, in this case, actually like to just turn this fraction into a whole number. And I can turn half into a whole number by multiplying it by 2, because half of 2 is just 1. And so this is just 5x minus 13. And over here, you have to distribute the 2 to both terms inside the parentheses. So you would get 2x minus 4 equals 5x minus 13. Take away 2 on both sides, so you would get 3x. Add 13 to both sides, so you would get 9, and so x equals 3. Let's just test and make sure that this actually makes sense. If x equals 3, then that means that 3 minus 2 equals 1. And 5 times 3 is 15, and 15 minus 13 is 2. So is 1 half of 2? Yes, it is. So x equals 3. This one you're going to do the same way. Pay attention to how to find y, because y just means that these are congruent to each other. So you can go in here and set these equal to each other, and then do the formula where this is half of this. So I'm going to do y first because that's just a little bit easier, I think. So 12 equals y. And then just write this equation for x as you're thinking it in your head. 5x minus 3 is half of this. Again, I don't want the half there, so I can multiply it by 2, and that would just become 1. It's 1x plus 112, so it's x plus 12. This also needs to be multiplied by 2, so make sure you do this step or else the entire problem will be incorrect. And this last problem is dealing with a triangle that's on a coordinate plane. So let's go ahead and graph these coordinates. You have A at -4, 1. So there's A. You have B at 8, 8, -1. And you have C at -2 and then +9. So that's going to be all the way up here. So here's my triangle, and we want to find the points D and E, where D is the midpoint of CB, so D should be around here somewhere. And E is the midpoint of AB, so that should be around here somewhere. So remember, midpoint, midpoint, what do? You just add the points together and then divide them by 2. So let's do CB first, so that way we can get coordinate D. So CB has the coordinates -2, 9, 8, -1. And if I add these together and then divide by 2, I realize that D is located at 3, 4. So if you go back to your coordinate plane, 3, 4, we guesstimated correctly this would be point D. Do the same thing to find E, which is the midpoint of AB. So I need A and I need B. And again, we guesstimated that correctly because here's E at 2, 0. We also need to verify that AC is truly parallel to DE. So that's the segment that we just found and I just drew in here. And remember, you want to find that two things are parallel to each other if they have the same slope. So we could find the slope of AC. And we can find the slope of DE. And if we compare them, parallel lines have the same slope, so these should be the same fractions. So let's go in here and do all of our coordinates. I like to just do this first and set it up. And remember, slope starts with S and so does subtract. So we're going to subtract to find the distance between these 2 points first. Once I subtract, I slide this underneath, and then I simplify to find that this has a slope of 4. And I do the same thing over here because 3 minus 2 is 1 and 4 minus 0 is 4, and so I slide the 1 underneath the 4 to find the change in y over the change in x, and I get that the slope is also 4. And so since the slopes are congruent to each other or equal to each other, these lines are in fact parallel. So, all right, you guys, I know that was a pretty long lesson. There's just a few more questions below this on the Go Formative. That was the last video lesson. Do the Go Formative below this and then submit that. And then there's just one more Go Formative before we do our test.